Network troubleshooting using Wireshark.
Okay, so you've probably been in a situation where you've been in, say, an airport or a coffee shop, or any sort of public place where they offer Wi-Fi, and you run across what is known as an open Wi-Fi network. Now, what do I mean? An open Wi-Fi network is one where there is no authentication to get on the network. You don't have to enter in a password or WPA passphrase to get on. You just click the network and then you get on. And so what I'm going to show you today is a freestyle where we go through a packet capture from one of these networks. Because the problem with these networks is as follows. Say this is an example network. Say this is a coffee shop, right? And you have multiple people over here who all have, PCs or laptops or phones, all connecting, via wireless to the router, and then the router connects to the internet, okay? The thing about open Wi-Fi is that the communication between the PCs and the router, so all of this communication here and here is totally plain text, meaning anyone, even if they're not associated with the network, so if I'm just sitting here, right, this is my Script Kiddie PC, and I'm sitting here with my laptop, I can use a special wireless adapter to listen in attached to my PC and actually sniff all of this traffic. Okay, so all the traffic between the PC and the router, between the PC and other PCs or devices on the network, I'm going to be able to see. And I don't need a password or anything to do it. This is why people advise you not to join open networks, or if you're going to join them, to use something like a VPN. Now, quickly before I get into the capture itself, the reason a VPN is useful is this. Now, there are some protocols on the internet. Get rid of this guy here. Some protocols on the internet which are known as encrypted, meaning from your PC, if you connect to, say, a web server, say there's a server over here, okay? This is Google. And I'm connecting to Google through my router, through the internet to Google, okay? And it is encrypted to the protocol that is, or is using an encryption protocol. So say this is like, for example, TLS, which in the web is HTTPS, okay? What that means is that all the traffic and all the packets between my PC and the server are going to be encrypted. I can't see them. Even if I listen from here, say I have a sniffer set up here and I'm listening, I'm not going to see anything because it's encrypted end to end. It's because it's using an encrypted protocol directly from the PC to the server. Now, not every protocol is encrypted. Even in this day and age, with security is so important, and a lot of vendors are moving to more secure protocols, there are protocols that are still not encrypted. For example, DNS is not encrypted for the most part, right? You have HTTP, which is basically websites accessible over the HTTP protocol. Oh, sorry, that's HTTPS. HTTP. That is not encrypted. This is usually on port 80 TCP, okay? And you have other things like LDAP, right? Not encrypted, or at least some of the messages are not encrypted. You have things like MDNS, which announces to other clients of the network who you are, what services you're running. That is also not encrypted. So when you do this attack, if you are capturing traffic, say from the entire Wi-Fi network, there is going to be some traffic that you're not, even if you capture it, you're not going to be able to see what's going on. You're not going to see what the user's doing, right? So if this user is connecting to Google, you'll see that they are connecting to Google. You're going to see the record that they're connecting to that web server. You're not going to be able to see the content of their traffic, okay? But for all these protocols here, if someone sitting in this coffee shop is able to sniff all the traffic here from these machines, they're going to be able to interpret a lot of information about you and a lot what's going on in the network, okay? So let's get to the capture. All right, let's get into it. So the one thing I didn't mention in that previous segment that I want to mention now, a VPN allows you to encrypt all of your traffic in flight between your PC and the VPN provider, right? So say you use like a company like OpenVPN. What the VPN client on your laptop will do, or your phone, is make sure all the traffic, even if it's plain text, usually like things like DNS, it's going to encrypt it into a tunnel and send that tunnel all the way to the this DNS, or sorry, the VPN server. Okay, so if you're in that coffee shop scenario, attacker's not going to be able to see any of your traffic. All right, so I was at a ski hill recently. I was sitting in the lodge. My family was out skiing. I decided to pull up my laptop and take a capture. At a later date, I may do a video on showing you how to do that capture. It's very simple. You need a Linux machine with a few tools. But I took a capture that's open, and we're going to dig through it. So let's load it up. And we're going to look at some of this traffic. Now, the first thing to notice is that you're going to have all of these white packets here. These are actually not packets in a strict sense. They are frames. Frame is effectively just a datagram at layer 2. But what these are basically signal messages between all the different clients on the wireless network to talk to each other. And why do they have to talk to each other? Well, wireless is a shared access medium. If you want to learn a little bit more about that, look at my video on how to DOS a wireless network. It'll explain that wireless, on a given wireless network, only one host or one radio, so like one phone, one PC, one AP, can be talking at once. So in order for that to happen, all the different hosts need to be talking to each other all the time using these control frames. But what they're not doing is exchanging data. They're basically arranging to see who is actually going to be allowed to talk at that point, right? So the a radio or a client, basically this is a device, will signal to the others, hey, I need to send traffic. And then you'll get a clear to send, which means basically is the AP saying, yeah, you're good to go, send the traffic, and then you'll actually see traffic come out. So in this capture, the white lines are the control frames, and anything that's colored are actual data packets at the layer 3 IP layer. So these are interesting. You can kind of look through them and dig through the dissection to understand how 802.11 control works. But for now, I actually want to strip these out because I want to actually look at the data. So what I'm going to do is I'm going to try to make a filter for this. QoS data. I'm going to try this. So I'm going to right click. I'm going to apply as filter, not selected. And so that takes what the value was here, it puts a not on it, and then it filters. Oh, okay, that's not what I wanted because now I only have white. So let's try again. Let's take that off. And then let's go look at what we can do. Frame type control frame. Let's see if we can apply that. So let's apply as a filter. You can't really see this. Let me move it up. Right click, apply as a filter, not selected. And that seemed to work. Okay, so now I only have the actual data packets that are being exchanged by all the hosts on the network. And before I actually dig into any of these packets, just a few observations as I scroll. One is I see a bunch of different protocols. I can tell that because Wireshark usually colors protocols with different colors. And also, you can see there's different ports being used. TCP 80, I mentioned that was HTTP. You have some other protocols here. Let's see. A lot of TCP, some reset packets on TCP. We have some, I don't know what this port is, but 21001. I saw some DNS. Before we dig in, let's do some high-level statistics. So statistics. Let's look at endpoints. And let me just get this into the right place. Now, endpoints is a statistics report that will show you all the different IPs, or if you want Ethernet layer 2 hosts, but let's just stick to IPs. All the different IP addresses that are seen in this capture. And now with an open capture of a Wi-Fi network, you're going to see two types of IPs. You're going to see public IPs and you're going to see private IPs. Public IPs meaning IPs that are used on the internet. So these are outside the network. These are probably IPs which the PCs on this network are communicating with. And then you're going to see private IPs. The private IPs usually fall into a range like 192.168 or 172.16 or 10 dot, what XXX 10 dot whatever. Those are considered private IPs. So if I want to see how many different devices are on this wireless network, I'm going to look for the private IPs. And in this case, I see I've got 192.168.50.1. So the subnet that is being used in this network is 192.168.50.0/24. And I'm going to make a safe assumption that .1 is the gateway. So this is likely the wireless router. And then I have something like, I don't know, I want to say that's about 30 different IP addresses. Okay. So all of these are devices that were in that ski lodge that are connecting at any given time. You can also observe how much traffic each one of those devices is sending and receiving relative to the others. So right away I can tell that this one IP, .116, was, looks like it transferred a total of 68 megabytes in the time that I took this capture, versus the others, which look like they have some traffic, but not that much. So that's a person of interest or a device of interest. I could certainly apply as a filter and do selected, and then just look at the traffic for this one IP. But for now, I'm going to stay high level. So I can tell there's something like 30 different hosts connected here. We have some more public IP addresses. If needed, you could go through these IP addresses to figure out where they are. But it looks like it's a fairly busy network. Now, the other thing we can do is statistics conversations. This is going to show you like specific conversations between two IPs as opposed to just or individual IPs. So you can kind of get a sense of like which connections are actually using the most data. So similar to the previous window, you can see there's now, instead of one list of IPs, there's sets, there's tuples. And I can see the same kind of data like packets, bytes, how many bytes was transferred from A to B or B to A, etc. So what I can do is I can filter that or sort it. I'm going to sort it by bytes. And I think this is the same IP we just looked at. You can see the 23 megabytes being transferred. It looks like it was data from A to B. In this case, A is the public IP address and B is the private IP address. So this looks like a download. My guess is this is probably streaming. One of the things you can do as a quick test to validate IPs is actually just get your command prompt and do DNS Lookup on the IP address. So if I say I want to do 104.18.31.133, you can't find it. So if it's not in DNS, the next thing you can do is IP lookup. And let's find who owns the IP. So let's do this. This is Cloudflare. Okay, it's not as helpful because Cloudflare could be effectively a network service provider. This could be any website that that's hosted on Cloudflare. So from the IP address alone, we can't tell, but at least we know high level, who the top talkers are, who the top conversations are. Now let's get into the actual data. So in this filter, again, we're just looking at the data packets. I could see there's tons of data on port 80. So I want to look at that. But the first thing I want to do is just do a simple and DNS. I just want to look at DNS packets. I mentioned in the previous section that DNS is plain text. So all the requests that are coming from the various PCs on the network to DNS are all plain text. You can see that right here. These are all the websites that these people are visiting, right? And you could very easily get a sense of what it is. Like some of the websites are a little bit obscure, but you can look at here, Alibaba DNS. This person is likely using an Alibaba service, right? iCloud. We can see here we have Apple. We have, again, more Alibaba. We have Alipay. Like, I mean, there's a lot, JPush. Like, so you could get a sense of effectively what these devices are connecting to and what services they're consuming. So if you're a malicious actor, you could start fingerprinting this person, and if you want to select one person or the whole site, and figure out, well, who's going to what? Is anyone going to a website that I can, exploit in some way. But this is all plain text. You could also, if you need to, export this list into like an Excel file, and then you can do a study on it later outside of Wireshark. You could do some kind of statistics, things like that. But this just gives you an idea of every single website that is being accessed by these resources, right? So that's one thing, is DNS. The next thing I want to look at is HTTP. So I mentioned again in the previous section that there's HTTP can be encrypted or not encrypted. If it's just HTTP, it is the unencrypted version. If it's HTTPS, the S is for secure. That's the encrypted version. Now here I can see that Wireshark has flagged a bunch of stuff as HTTP. And if I take a look at the section here, I'm going to look for TCP layer. I can see the source port is 80. So this is unencrypted TCP. Now I don't know what this person is doing. Remember, the IP addresses here was the same one that was the top talker. So what I'm going to assume is that this this connection here that's going on, this is likely going to be some kind of video streaming. This person is probably watching some video and downloading it over plain text. So let's just see what it looks like. I right-clicked and I did follow TCP stream. And what this will show me is exactly what this user is trying to get. Okay. They're trying to download this file. This looks like a chunk of a stream, right? So when you're streaming something from like YouTube, it downloads it in chunks, which are just pieces of the video. And this looks like a chunk. You can see the website it's downloading from, some kind of website in China. And you can see other information about the host. This is from the information in red is about, like, say, the iPhone or whatever device the person is using. And this gives you information about them. So this helps you fingerprint the device that's being used. Over here on blue, this is what is known as the HTTP response headers, which is from the actual web server you're connecting to, a response telling you all the information about the web server as well as the file. Okay, and remember we did that IP lookup to figure out what it was, and that was the IP address, right? 104.18. Now I can associate that with app.xhs.cn, because now I know, before it wasn't in DNS because I was doing a reverse lookup. Now I can actually see it, and I can confirm that by doing DNS lookup to this. Oh, interesting. So that doesn't exist. Okay. More on that later. Maybe that's a bogus referrer, which happens, but we'll take a look at that later. Anyhow, then I'm going to scroll down and see what's going on. Oh, we have a different host name here. I wonder if this is the host name. You have all these other fields here are parameters of the video. Okay. You may even be able to pick out the name of the video this person's looking at. But let's just see if this host name resolves to that IP address. Copy, paste. No, it's a different one. Okay, that's maybe a different video. But this is video information about the video they're downloading. Now, this data here is likely the actual video data. It's just we're not going to be able to make any sense of it because it has to be decoded using the right codec for the video. But all the other information at the top of this is all like information that attackers would go crazy for, to understand what you're accessing, why you're accessing it, if you're doing a video, if you're doing actual text, as well as a bunch of data on the actual video that you may be looking at. So that's that one person. Let's see if there's any other HTTP. So I don't want to look at 116 anymore. What I'm going to do is I'm going to do a filter for HTTP and not IP.address 192.168.51.116. This is going to show me everything that's HTTP, but not from this IP, because I don't want to see this conversation anymore. Let's let that load. All right. So there's others who are using HTTP. It's not that much, but let's see what's going on. So we have some gets here. For example, 160 is doing some, let's look at this get, follow TCP stream. Let's see what they're trying to do. So they're trying to do a get of some big file to df.tanks.com. I don't even know what tanks.com is. Please don't be something inappropriate. Some kind of Chinese website. The language was also Chinese, so that was probably a giveaway. It's telling me it's an image. Oh, looks like it's a GIF or GIF. So that's interesting. The actual GIF data looks like it's not in the file, but if you actually have plain text HTTP and there's images in it, Wireshark also allows you to export those. I don't think I can do this one because the actual data wasn't captured, or at least it's very tiny data. But if you want to, there's an option under File, Export Objects, HTTP, and you can actually export things like videos and photos. I'll do another video on that some other day. But you can actually see the file names of the videos MP4 here. This is that, again, that one person who was doing the streaming. And other file names as well. So again, all this stuff, again, totally accessible to people who are just sitting nearby and sniffing the traffic. There's some other HTTP here. Let's just see what this looks like. This might be the same thing. And yeah, this is the same request for that GIF. So if that was a sensitive GIF, well, it's now being seen by people. Let's go back to our original filter of this one. And let's just go do some scanning. So we looked at HTTP, that was plain text. We looked at DNS to get a full record of everything people are connecting to. Let's see what else is in here. Let's look for an MDNS. Now, MDNS is a protocol that's used to basically announce your presence on a network to other people. So if I just pull this up again, MDNS would be like if I'm on this PC and I want to announce to this entire network that I have, like, say, a Plex server running, or I have like iCloud sync, or I have other services, I would use MDNS and I basically broadcast that out to everyone on the LAN, right? So it's basically a very noisy way of announcing your presence to everyone. So it's also a great way of figuring out what services are being run on your devices. Okay, so someone who is, nefarious. And right away, you can also look at a lot of things like names, because usually people, when they're actually setting up their host name for their phones, they use their actual like first name. So I can see here a bunch of different devices are broadcasting. This is the MDNS destination. It's called a multicast address. Multicast means that when it sends this to the network, it's going to distribute that packet everywhere. And the messages are here. Again, all of them are in plain text. And if you take a look through the MDNS message structure, you can see there are many different fields which include different pieces of data about that host. Now, some of them aren't that useful. Some of them are just for one specific application. However, just by eyeballing this, you can see there's some information that's being revealed. First of all, this person's got Google Cast on their device. That's obvious because Google Cast is being broadcast in MDNS. Let's see what else. We got HomeKit. Where's HomeKit? HomeKit. This person looks like they've got a HomeKit service, proxy service. Let's see. What else can we pick out? It's always good to just scroll through with your eyes and see what you see. This person's got an iPhone. That's not a surprise. Another iPhone. Another iPhone. Same iPhones. I think I saw someone's name just now. Julia's iPhone. So this person's name is Julia. I know that. And this is just displaying some of the information about her phone, etc., etc. So all this information, depending on the type of device, can be interpreted. This person's got Spotify. What I would actually suggest you do is, if you're interested in interpreting an MDNS message, take the message and actually export it. You can go to File, Export Packet to Sections, right? Send it to something like ChatGPT and say, hey, I have an MDNS message. I need you to interpret it for me. It'll do an amazing job at it, right? Because the messages can be specific to the device type. And so it doesn't make sense to actually study these to understand what each of these messages mean. All that really you need to know about MDNS is that it exposes service information from a device. And if someone can just sniff it, they can get a lot of information about your device that you don't want them to have. Okay, so that's MDNS. So let's go back to the capture, look at maybe one or two more things, and then we'll end off. Okay, so we have the quick protocol. This is like a new age web protocol used by people like Google. We got more DNS. We have some ARP. ARP is really just to find out MAC addresses to IP addresses. More TCP. If I'm going too fast, apologies. Let's scroll through. What was that? That was ARP. Okay, I'm going to do something here. I'm going to do and TLS. So we covered already plain text HTTP. Now we're going to do the encrypted version. Now, I'm not going to be able to see into the packet data like I was doing with HTTP, but HTTPS still has a lot of information that's valuable. Part of the TLS handshake, there is a process where the actual host name of the resource you're connecting to gets exposed. So even though I'm not seeing the content of this communication, I can see some information about like what resource they're trying to get to. So in this case, for example, I have a client hello message from TLS from 116. This is my favorite person on this network, connecting to 228. And if I go into the TLS layer, I should have an extension for server name. So this is known as the SNI, server name indicator. This will tell you the exact resource or the host header that 116 is trying to connect to. So if I write, I'm going to apply this as a column, okay? So I can actually see the server name. And what I'm going to do is I just want to see SSL handshake client hellos. So I'm going to do apply as filter selected. And this is going to show me all the different websites that are being connected to over TLS. Remember I mentioned that DNS will show you a record of that. Well, DNS will show you a record of that. Some websites, because of the way that the load balancing works in certain cloud resources, DNS is not going to tell you the actual resource they're connecting to. It's just going to tell you kind of the gateway that you need to get to. It's the client hello that's actually going to tell you the server name. So just like DNS revealing all the websites that people are connecting to, the client hello server name is also a great way to tell what people are connected to as well. Now, trying to get to the bottom of this mystery about this IP address, I couldn't find it in DNS. I couldn't find it in the HTTP host header. The server name indicator it's telling me is this here. So let's just for argument's sake, I really want to pin this down. SNS avatar qc dot xhsc xcdn.com. That's exactly what it is. So finally found the host name that this person is connecting to. This looks like some kind of content CDN for videos. That's not really that surprising, but I know that this person is streaming. I know the website they're streaming from, and I can have an idea of what video they're actually streaming. So that's not really that secure. I also see a lot of Alipay in here, like we saw before with DNS. I see other websites as well. Polaris, Teams. Someone's got Microsoft Teams running on the network, etc. Okay, so let's do one last scan through, see if there's anything else that's of interest. I'm going to turn back on the filter to get rid of 802.11 control frames. That wasn't the right filter, but that's okay. Oh, let's do this. I want to try to fingerprint each of the devices. So each device has something known as a MAC address. Okay, so the MAC address is basically a physical hardware address. Think of like the IP address as a logical address for the device. The MAC address is a physical one. This is like burned into the device in question, right? So if this is the phone, this MAC address is permanent. You can't change this unless you have like advanced security technologies like iPhone does. So the other thing about the MAC address is it generally, the first 6 characters here in hex, these are unique to the organization who made this device. So if you want to fingerprint like what devices are that are on the network, what you can do is actually look at the MAC address, and Wireshark can actually try to interpret which vendor it is. So here, for example, in destination address, you see it says WatchGuard. That's a manufacturer. Okay, so let's just apply this as a column. I'm going to get rid of the server name. And these MAC addresses are all here of all the devices. Now, you could go through it. I think Wireshark only shows it in the section down here. It doesn't show the manufacturers here. But when Wireshark does detect the manufacturer, it will make it show up. Right now, doesn't look like it's fingerprinting a lot of them. That's okay. WatchGuard. The only one it seems to have in its database is WatchGuard. Either way, what you could do is actually take an export of this, of all the MAC addresses, and there's tools online. It's called, look for OUI Lookup. Okay. And OUI Lookup allows you to actually put MAC addresses in here, and it'll tell you what the vendor is. So that's another way that you could actually get some more intelligence about the devices, right? Is to actually look at their MAC addresses and figure out what they are. There's other ways you can look at it too, like you can look at the MDNS, like I mentioned, to figure out what it is, and other ways of fingerprinting, but it's just another way that you can actually turn one of the pieces of information you find into something that is usable as an attacker, right? So I'm going to stop there. There's more that we can go into. We can talk about digging into one individual host and figuring out more information. You could, at this point, if you're a nefarious actor, you could do something like a man-in-the-middle attack, where you're actually getting between the data and injecting data into the client. You can do denial of service attacks on this network. There's so much you can do. But really the point is that I want to make is that open Wi-Fi allows for this to happen. If you're in an airport, if you're in a coffee shop, if you're in a restaurant, if you don't know exactly what protocols are being used on your device, someone can very easily come in, see a lot of your traffic, know what websites you're going to. And if they're really good, they can start fiddling with you. Like say you're in a coffee shop for a long period of time, and they can actually set up an attack. They could potentially like get your credentials. They could potentially do a man in the middle, right? There's lots of stuff they can do. So the way around this, there's twofold, right? One is only really connect to web networks that you trust. So a secured network that has a password, the password isn't like written on the wall of the restaurant, right? That would be number one. Number two would be to use a VPN client. Now, as I mentioned, when we first started talking about this, what a VPN client does is, just want to get rid of some of this stuff here, just bear with me. Fast forward. Power. Okay. A VPN client runs on your PC, and this is the VPN server, okay? And, sorry, I gotta get rid of this. It's just bugging me. Boop, 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 boop. VPN client does this. All your traffic from your PC, okay, gets routed to the VPN server first, and then to the internet, to wherever you have to go, whether it be to other websites, Google, Amazon, to DNS, all those services gets sent in an encrypted tunnel. So the way that we looked at traffic before in Wireshark, if I had a VPN software running on my PC or my phone, and I connected to that network, I would not be able to see any of this from my IP, or an attacker would not be able to see any of this from my IP. All they would see is one stream from my source address to the VPN server and nothing else. They would not be able to see anything in that They would not see any identification information. It would be all private. And that's why people try to sell these VPN services to you, because if you're in an unsecured network, here, this segment is an unsecured network. And to be fair, the outside segment, if you know the kind of stuff the NSA does, is also unsecure, or insecure, I should say, right? Or sorry, insecure. So a VPN service allows all that traffic to be sent to a third party. So this is the VPN server provider. And then from there, your traffic gets onto the public internet. So it's much more secure if you're using these networks. The only thing I would say that's a concern is that the VPN provider has a full log of everything you do, right? So if you do stuff that's nefarious, you won't see it here, but you know, the FBI might ask them for this log at some point if you do something really bad, which you're not doing because you don't do those things. But it's one consideration. But in this case, if you're just a regular user and you just want to have a little bit of security, like, you know, you can subscribe to one of those VPN services for a few dollars a month, have it on your phone, have it on your laptop. And then when you do travel, like if you, or you do spend time like on campus or somewhere where there's an open network, just turn it on. And then you have some peace of mind that some, you know, script kiddie machine isn't sitting here and sniffing your traffic. That's it for this video. If you have any questions about Wireshark or networking, feel free to post it in the comments. We can chat about it there, or you can always send me the capture file to take a look at. I have a Dropbox that I'll send you to send the file. I've also got a Discord server now, so you can check it out, that channel, and join to do the same, post questions about networking, issues you're working on at work, etc. And as always, please like and subscribe to support the channel. Until next time.